Oh, hi. I was doing section 11.1, number 30, and I wanted to share something weird that happened. I just had a bad idea, and I want to show you how bad it was. The sequence 1 minus n to the third over 70 minus 4n squared. I got the feeling that this was going to positive infinity as n goes to infinity. I got that feeling because, look, I had a negative n in the numerator and negative 4 in the denominator with some terms that become negligibly small as n becomes large. So I expected a very large negative number over a negative 4. Okay, right. And then, to show that this was the case, I said if m is a real number, I want to emotionally think of capital M as a large integer. I want to show that 1 minus n to the third over 70 minus 4n squared is even bigger than m when I put some conditions on n. Okay. So what I did is I said I want to get an expression which is smaller, so I'll replace the numerator with something smaller. And so I just replaced 1 there with 0. Okay, that doesn't hurt anybody, right? But then in the denominator, I did something weird. I saw 70. I said, okay, I want to replace 70 with something bigger than 70 to make the ratio smaller. And I said, look, for 70, I'd like to have all of my terms of the denominator be to include a factor n squared. So I replaced 70 with 70 times n squared. Now I did that. Instead of just replacing 70 with just n squared, I replaced it with 70 times n squared because I was thinking about when n is 1 or n is 2. N squared is certainly not bigger than 70 when n is 1. So I put this in here. But then see what happened? I messed with the denominator and changed the denominator so that for large values of n, I have something positive down there. And then I was thinking, my gosh, I wanted to show that I had a negative number over a negative number, but I don't anymore. So something weird happened, and I don't like it. I think what I did is I put in just something way too big, right? I replaced 70 with 70n squared, and that's just gigantic. So I think what I need to do is that, right? Just put in an n squared, and that will give me a negative 3 down there. 3, kind of squeeze that in there, the negative sign, and that'll give me a 1/3 times n. All right. Now, thinking about that, it's not true, right? I replaced 70 with n squared, and 70 certainly is not. Let's see. I wanted to say that n squared is something bigger, but this just isn't true. So what I will do is say that n squared actually is bigger than 70 if n is big enough. Bigger than, say, 70. Okay, so I'm going to keep that in mind, and then I'm going to say that I can make this. I can say that this expression is bigger than capital M when I have some relationship between m and n that right here will be good enough. Okay, if let's see, n is bigger than some expression n sub capital M, okay, which I'm going to define to be some expression involving m, namely 3m. Okay, but I want to make sure that all of my n's are going to be bigger than 70, so I'm just going to tack on 70 here. Okay, and then apply the ceiling function to make sure that I get an integer. And now, when n is that big, we are definitely going to have that all of these inequalities hold because I added in 70 here. I forced n to be bigger than 70 in particular.